So basically, what diabetes is, it's a debilitating disease, and it refers to the body's inability to respond to or produce insulin. And what insulin is needed is to control the glucose levels throughout the body. And if that isn't controlled, excess glucose accumulates throughout the body. And that can cause health problems and lead to significant discomfort. And currently, diabetic patients need adequate glucose readers to make sure their blood sugar is stable from time to time. And glucose readers are a class 2 device, which means that they have a moderate to high risk of danger to the health of the patient. And if any of those measurements are inaccurate, it can spell worsening significant health issues. And current glucose readers require the patients to draw blood from the body, such as needle pricks, finger pricks, and those are inconvenient as opposed to our proposed solution. So our proposed solution was to identify the correlation between blood glucose levels and eye redness. And the eye is a good indicator of health and blood glucose levels because they contain blood sugar. They contain blood vessels that are easily identified and observed. And if we identify the correlation between blood glucose levels and eye redness refers to the widening and dilation of eye blood vessels. We plan to create a software to better observe and analyze blood glucose levels and eye redness, and to improve the health of the patient. So, components. So, in our project, we have 3 parts. The first part is the camera on a smartphone, on any smartphone, whether Android or Apple. And its purpose is to produce clear and concise images of the eye, particularly the blood vessels of the sclera. And the second one is energy bar or food bar or chocolate bars. So their purpose is to be sugary foods that spike or elevate the blood sugar levels throughout the body. And the last one is Photoshop, and its purpose is to assess and analyze the images taken from the smartphone. So our test procedures. So basically what we did was we had 4 subjects, anonymous subjects, with varying levels of body metabolism, and we each fasted for 12 hours straight. No food except for water. And we did was that we took a photo of our eye before the fast and after the fast, and we compared it and plotted a graph. So we observed that over the period of 12 hours there was a gradual decrease in blood sugar levels, as opposed to there was a decrease in eye redness as opposed to time, and this could indicate that blood glucose levels and eye redness are proportionally related. And we also created a second experiment, which we had 2 subjects with fairly faster metabolism levels to eat a chocolate bar or energy bar to observe how their body would respond to sudden increases in sugar. And we observed that over a period of 1 hour, from post-fast to after eating the chocolate bar or energy bar, there was an increase in eye redness, which indicates there's an increase in blood sugar levels. And the purpose of this was to analyze how people with faster metabolisms respond to sugar as opposed to slower metabolisms. And while there's a significant increase in eye redness on this graph, on our pictures there wasn't really much of a difference, and it's mainly based on the patient's lifestyle. So the patients may be physically active and doing strenuous activities that have their body to basically digest sugar faster than others. And conclusion. So we've identified that there is a correlation, a proportional relationship between eye redness and blood glucose levels. And we plan to create a blood dilation sensor that better improves the health of diabetic patients. And future goals. Since we identified that there was a correlation, we plan to create a software for iOS or Android to allow patients to have a weekly log of their blood glucose levels from, for example, on Monday they can take a picture of their eye and say, oh, my blood sugar levels was this, and on Friday they can take it again and see if it has increased or changed, and if it has, they can go to the hospital for a checkup immediately. And this can also be used by physicians to communicate with patients and share data among other physicians. And that's about it. That is it.
Professors?
Okay, so first thing is your concept. This is going to be a challenging concept for someone to actually believe would work. In order for you to actually do that scale bar, the way people do that is you actually compare it to the standards that exist. Hence, you get a blood sugar glucose monitor and do the invasive test alongside the non-invasive test. So if you are saying blood sugar levels are increasing, you can actually quantify it, right? You're like, oh, this person did XYZ. Well, this is the blood sugar thing we got from the non-invasive one, the standard compared to ours, and see how yours compares to the standard. That's what people would typically be looking for if they're going to assess the credibility of your work. Because if you're thinking of blood sugar levels and the people that have to worry about it, there's a strong chance they're already going to have other medical complications if you're thinking of type 2 diabetes for people that are older, right? And type 1 diabetics would have been diagnosed and they already know they have the disease. So I think it's a very cool concept, but that's something you have to keep in mind if you're to continue this project. Comparing to the standard will greatly validate the, how do I want to say it, the idea you're pushing forward, because it is a very good idea. The other thing is your results. A lot of students do this, so it's not uncommon, and it's good that you're in an early stage. The graphs are not very clear, so it's good that you have graphs, but I don't think anybody's going to be able to see them, right? And you see how small they are. You can thicken the lines. You can thicken. I don't know if you plotted them or you just screenshotted them.
A member of my group plotted them and I screenshotted them.
So you should try to make it as visible as possible for people to be able to see and detect what you're doing. And I mean, tables can be improved as well. It seems like everybody's following the same template, so everyone's stuff is wordy. I'll try to reduce that if possible. But those are the key things I would say. And so the fact that you see that correlation is great. Before and after eating.
Well, and the only question I have is your time scales. So if your measurements are hours prior and hours after, I mean several hours after a person eats, I mean glucose level can vary in a matter of minutes after a meal. So if you gotta wait a few hours to actually see a noticeable difference, then that could be a problem too, because you want something that can that you could use that could react quickly a matter of minutes after consuming a meal, or something like that. Because otherwise, if you're looking at hours, then maybe not so useful, and certainly not measuring something on Monday and then on Friday again. That definitely is not going to be very useful either.
Why is that person's eye like that? The one on the right.
Oh my.
No, but did you pull your eye? Like.
Yeah. What?
Something really surprising just happened.
Right.
Yeah.
Is that person just looking? Did you pull up the eye? Or like, what's going on? Do you have to do that to take the measurement, or?
I like opened it as wide as possible, so
Okay.
like they could show like more of the white areas.
Okay.
Yeah.
So novel concept, but I think there's some things I need to flesh out to just make it come across as more solid. You know, I mean, I don't know if you're gonna have time to do what I'm saying, but that's something I'll strongly suggest um, to include, because you guys tested yourselves, right?
Yes.
Okay. So if you tested yourselves, then no need for IRB or anything. Just
So if there's something out in the market that is similar to this in concept or
We did some research and there wasn't a device on the market. There was another company. I forgot their name. They were doing a similar research on identifying the red pixels in the eye and relating it to blood glucose levels.
yeah, because it's a tough one, because what you're really doing is just saying, I want to measure the vasodilation in the eye. There are other things that are vasodilators, right, that have an impact on the eye. So those are things you're going to have to be aware of. If I drink coffee, what happens?
That's what.
Whether it's vasodilation or there's some things that will vasoconstrict, some things will vasodilate. So all those things, you need to understand the general concept of those so that you understand the limitations of your study. You can't just say, oh, I have sugar in my system, my eyes are red, right? First thing that will come to mind as well would be people's tiredness level, their intoxication level, all those other things as well would play a role.
and then what was the purpose of those color squares you have in the middle?
Oh, that was to distinguish the skin color, the skin pixels and the eye pixels. So distinguishing the skin whiteness as opposed to the eye whiteness.
And when you're suggesting the app, I think, I mean, it doesn't necessarily have to be a picture, right? It could just be whatever inputs. Even if you open your eye, look at it, it gives you a feedback or gives you a number or something.
Yeah, I guess it didn't. I've seen this group kind of work a little bit. Didn't you test some blood sugar levels at some point a while back, or has it never been done?
Oh, you mean like
Yeah.
yeah, this is a continuation project. So I was actually working with William and Pranav and Stephen Trey, and then William continued that.
Okay. Did you guys actually do blood sugar tests though?
Like the invasive one?
Yeah.
No.
No. Oh, that's okay. And I'm just kind of curious. Can you give your graphs again? Scroll down. I'm just having a hard time since we talk about reading. What are the red and blue lines?
Zoom in.
Yeah.
All the way down, just for the graph. All the way up.
Okay, so subject 1 and subject 2. Small, large. And how many data points did you?
Um,
take? Okay. Well, you said 4 for subject small meal and 1 for a large meal.
The other thing you want to think of is when you're talking, you're almost a little too positive. What you want to do is balance that out so you disarm your audience. You could indicate things like, okay, while we don't think this is something you could use right away, the correlations we see are very positive, and we believe it could eventually translate to us monitoring blood sugar more effectively. You know, those kind of statements. And I think they gave a company here $100 million to come up with a non-invasive glucose test, and they didn't come up with anything, and they blew through all that money. Yeah.
We'll start out with $100. But yeah, next year I guess if whoever continues, we'll see if we can purchase a glucometer.
Yeah.
It's something to put in the bucket. other last minute comments, questions? Headhunting? Okay, good. Alright,
Thank you.
and last we have Ben, our secretary.
Oh, don't call me out
Do
like
you guys
that.
want to take a little break?